In a traditional application, the network location of service instances are usually quite static and can be therefore loaded from a configuration file that is manually updated from time to time by system administrators. Unfortunately, this solution hardly works when it comes to a modern microservice-based application that runs in a containerized or virtualized environment where the number of instances and their locations change dynamically. This dynamic nature comes from the fact that services' lifespans are usually measured in seconds or in minutes due to them being scaled up and down, upgraded, or simply failing. Consequently, we must implement a mechanism that enables services to locate each other in order for them to communicate through their APIs. And such mechanism is called Service Discovery. Although there are many possible implementations of it, they usually contain both a central server that maintains a global view of the service's network locations called a registry, and clients that connect to it in order to update and retrieve them. I'm Raz, and you're watching Explain It to a Duck. The Service Registry is a highly available database containing the network locations of the various service instances and is the key component to the service discovery mechanism. Unlike any other services of the infrastructure, it needs to be deployed at a very well-known and fixed IP address in order to be easily accessed. In short, it allows services to register and unregister themselves upon startup and shutdown by sending their network location and other information such as their name or their version number, for example, in order to let other services know of their existence. And to do that, there's two possible methods. The first one, which is by far the easiest, is self-registration, as it puts a service in charge of managing its own registration by directly connecting to the registry. However, this approach couples the service to the registry, as the registration logic code must be implemented in each service. The second method is the third-party registration, where a component called a registrar tracks the changes of the services inside the running environment and automatically registers or unregisters them according to their status. It's quite great in a sense that there's no need to implement the registration logic in each service anymore, but it introduces a new highly available and sensitive component into the infrastructure that needs to be carefully set up and managed. Let's now go over the two possible patterns of service discovery, the first one being called Client-Side Discovery. When using the client-side discovery pattern, the client is responsible for fetching the network locations of the available services by querying the service registry. It allows the client to make application-specific decisions by load balancing requests across them using algorithms like round robin, for example. The main problem with this pattern, though, is that there must be one implementation of the querying logic per client, and so potentially per language or framework. For example, one in JavaScript for your website and another one in Java for your Android app. Let's now move on to the second pattern called Serverside Discovery. When using the server-side discovery pattern, all the client needs to do is to send its request to a router that will be in charge of querying the service registry and rerouting all of the incoming requests to the available service instances using its own load balancing algorithm. The advantage of this pattern is that the discovery logic is taken away from the client, but you have to keep in mind that it introduces a new sensitive component that needs to be carefully managed, as the load balancer must be highly available, since without it, no request will reach any of the services. And that wraps it up for today, guys. Thanks for watching the video. Feel free to share, like, and comment if you find this content useful, and see you in a week for another episode of Explain It to a Duck. Cheers!